Okay, I think it's time for us to get started. This is What's New in Windows 10 Deployment. My name is Mike Niehaus. For the next hour and 15 minutes, we want to talk about kind of the changes in Windows deployment over the last year or so. Some of that will be just kind of a rehashing of what's changed with Windows 10 overall, but we want to spend more time just talking about some of the enhancements that we've made as we've gone through each of the Windows releases. Before we get started on that, it's worth pointing out what's really happened since the release of Windows 10 16.07. That did come out as a current branch release on August 2nd. For those of you who aren't familiar with Windows as a service, that's basically the indication that this is a new release of Windows. It's ready for piloting and evaluation. After about 4 months, we then declare that it's ready for broad deployment by saying it's a CBB release. We made the announcement on November 29th saying that we've reached that CBB milestone for Windows 10 16.07. That then would normally start the countdown on the N-2 version. So this is the first time that we've gotten to that point of saying that because we now have a third CBB release, the first one is going to drop, that we're not going to service and support that release anymore. Now, typically, we would just have a 60-day grace period. So since we made the announcement on November 29th, 2 months after that, into January, we would say, okay, we're not going to patch the 15.07 release anymore. But we had some delays over the holidays, and because the media release process is kind of a bureaucratic, slow process, that we said, well, we'll go ahead and wait until the media is available, and then we'll start the countdown. So the full media wasn't available for Windows 10 16.07 CBB until it was posted to the Volume License Servicing Center on January 26th. So if you then did the math, it would be March 26th. That 60-day grace period would expire, and at that point, we would no longer be patching Windows 10 15.07, the original Windows 10 release. Now, we had a couple of other issues that affected a few customers, so we said, well, okay, we're going to stretch that a little bit this time around. So you'll actually see patches for Windows 10 15.07 all the way through May. So through May Patch Tuesday, and then after that, we won't publish any additional fixes for Windows 10 15.07. So you get a little extra time this go around. Hopefully, most of you have already moved on to at least Windows 10 15.11 and are already looking at Windows 10 16.07 and getting ready for broad deployment on that. If by chance you're looking at LTSB, if you've worked initially with LTSB 2015, it could be activated using the same KMS keys as all the CB and CBB releases. With the release of the new LTSB 2016 release that came out at the same time as Windows 10 16.07, there are new KMS keys, new KMS hotfixes for older operating systems. So you do need to update those if you're going to be using LTSB 2016. There are two sets of hotfixes then, one that initially added support for Windows 10, and then a second one that adds support for the new LTSB 2016 keys and also Server 2016 because it came out at the same time. You do need to install both of those to fully add support for those releases. So let's then talk about deployment choices. When we normally talk about deployment, traditionally we've talked about things like the ADK and MDT and Config Manager and things like that, which are still perfectly valid, and we'll spend some time on those. But that's the traditional model of deployment. We really want to shift the discussion more toward modern deployment and upgrades. For existing devices, we want to be able to upgrade them from Windows 7, Windows 8, or Windows 8.1 directly to Windows 10, preserving all the apps, all the data, all the settings. Because that's the easiest way to get from your current OS to the new OS. We also want to talk about how you deploy new devices, because most people today, when they're deploying a new PC, will get it out of the box, put it on a desk, plug it in, turn it on, and immediately wipe it and put a new golden image on it. We want to get out of that practice as well. As we move forward, we want to get to the point where we can take a brand new PC, plug it in, and keep the operating system image that it shipped with, and just transform it into an enterprise device. Now, we've been adding technologies to enable that, to do things like change it from Pro to Enterprise very easily, and we'll continue creating additional capabilities to simplify that as well. So for some of you, you might look at this and say, yeah, we're just not ready to do that yet. But as we move forward in time, you'll see more and more of an emphasis on doing that type of modern deployment or provisioning process to get the PCs ready. So let's start off by talking about upgrade. Upgrade has been a serious contender since the release of Windows 10. We've been pushing it as the primary mechanism to consider to get from Windows 7 and above to Windows 10. But of course, we pointed out some scenarios where it just doesn't work, that there are valid reasons to still do the traditional deployment. Things like changing from x86 to x64, because you can't change the architecture when you're doing an upgrade. Had to do a wipe and load in that case. If you're using Windows to Go or boot from VHD, neither of those support in-place upgrades. So if you're going to be using either of those, you need an alternate approach. Dual boot and multi-boot systems, you might be able to upgrade, but we're not going to take any responsibility for the bootability of the other OSs on that device, so use at your own risk. And some third-party disk encryption products can get in the way of upgraded PCs. Now, we made progress on that, and we'll talk about some of the changes that we put in to make that easier. But in some cases, you'll still be stuck. You'll have to either decrypt the machine and then upgrade it, or go through a wipe and load deployment to just wipe that off of the PC before you deploy the new OS. There were two others that were on our initial list, both of which we've now eliminated, or are in the process of eliminating. The first one is sysprepping after upgrade. We had customers who would create a Windows 10 image, say Windows 10 1507. The next Windows 10 release would come out, Windows 10 1511. They would want to sysprep that, basically deploy the original image, upgrade it, sysprep it, and recapture it. We didn't support that with Windows 10 1511. We do support that with Windows 10 1607. So today, you could take a Windows 10 1511 image, deploy it to a PC, upgrade it to 1607, sysprep that, and turn around and capture that as a new WIM. Now, I would tell you don't do that, because that's not a particularly good practice to go through, because hopefully you have a repeatable build process in place using MDT or something like that, where you just drop in the new media, push a few buttons, walk away, come back a couple hours later, and you have a new image. That's the preferred method, but if you don't have that level of sophistication and you do need to do lots of manual steps, well, okay, maybe deploying that, upgrading it, sysprepping it, capturing it, redeploying it is a better alternative. The other item on the list was changing from legacy BIOS to UEFI, because we've added new security capabilities in Windows 10 that didn't exist in Windows 7. Some of those require specific hardware configurations, like Secure Boot. In order to use Secure Boot, where the PC will make sure that it's booting valid Windows boot files, that requires using UEFI. Most PCs running Windows 7 today aren't using UEFI, even though they're on UEFI-capable hardware. They're using BIOS emulation. That BIOS emulation works great, but keeps you from using those security features. So as part of the Windows 10 deployment, a lot of organizations want to switch from BIOS over to UEFI, which isn't as simple as it sounds, because you need to do two things in order to carry that out. One is reconfigure the firmware to say you want it to run in UEFI native mode, and to turn on Secure Boot, which doesn't have to be done at the same time, but easiest to do it at the same time. And then the second piece is the disk layout has to be changed from MBR, which is the standard disk layout used today, over to GPT, which is what's standard for UEFI. So you need to do both of those steps at the same time in order to convert a PC over to UEFI. The tools were available from OEMs to do the first piece of that. Lenovo, Dell, HP, they provide tools to let you change the firmware settings, but there wasn't a supported tool for doing that for the disk. So we're working on that one now, a tool called MBR to GPT. We'll make that available with the Creators Update release coming up in the next couple of months, where you'll be able to run that tool in combination with those OEM tools to do the complete conversion of the machine in place. We've seen organizations that have built alternative ways of doing that now without that tool, but in order to do that, they've had to go through great lengths of capturing all the data from the existing PC, pushing it off to a network share, then reformatting the PC completely and pulling all that back down, which adds potentially a couple of hours to the overall time for doing that migration. So by using the MBR to GPT tool, we can simplify that and keep all the data local. That's available in the current Insider builds if you want to try it out. We've seen a few of our MVPs already posting on the experimentation that they've done with that. It works pretty well, and it's extremely fast. So when you take a PC running BIOS emulation with the MBR disk and convert it over to UEFI with GPT, it takes seconds. It takes longer to reboot the PC than it does to run the tools to reconfigure the hardware and reconfigure the disk. So very quick, and gets you to that point where you have a machine with the necessary security capabilities turned on to then layer things like Credential Guard and Device Guard and others on top of that UEFI PC. I mentioned the third-party disk encryption. A lot of the challenges that you have with third-party disk encryption tools, obviously we don't have with BitLocker because setup knows as part of the upgrade process, automatically suspend the BitLocker protectors, do the upgrade, and then turn the protectors back on when the process is done. But we didn't have a good way of doing that same thing for third-party tools. We didn't have a way for them to hook into the upgrade process. Some of them figured out ways of doing that and released 5-page documents that explained how to go through the process of doing that by mounting the install.wim, mounting the boot.wim, injecting drivers, injecting configuration files, and just really messing with the media. With the Windows 10 16.07 release, we added a command line switch to simplify that. So now the ISV can provide a folder, basically a set of files that needs to be injected, and setup will take care of injecting them for you. Greatly simplifies the work. It just requires that the ISV do a little bit of extra work to package up that set of files and give them to you to add into the upgrade process. Now, if you're doing upgrades using media, where the media includes setup.exe, you just run setup.exe with a bunch of command line switches. You can just add one additional switch called reflect drivers and then specify the folder that contains those extra files to inject. But if you're using WSUS or Config Manager's Windows 10 servicing capability, that doesn't allow you to directly manipulate the command lines, so you need an alternate method. So one of the other things that we documented with Windows 10 16.07 is the ability to use a file called setupconfig.ini. This setupconfig.ini file just needs to be in the right place for the upgrade process to find it. It will read that file in, see additional command line switches in that file, and append them to what it's going to do as part of the upgrade process. So even if you can't modify the command line with WSUS or Woo for Business or Config Manager servicing, you can add additional switches to do things like third-party disk encryption, language packs, drivers, or any other things that you can do to set up via the command line options. So you get a little bit more flexibility that way. The downside is, let's say you're using WSUS, you want to be able to use these third-party encryption products during the upgrade. It means that you had to have some other way of getting that setupconfig.ini file and the folder of files that it references out to the PC, whether that's a startup script or a login script or some software distribution tool that you're using to push that content out to the PC in advance of the upgrade. Doesn't matter how you do it, it just needs to be done prior to trying to run the upgrade. So it does require a little bit of extra work on your part to get everything staged onto the machine before it runs the upgrade process. Same basic thing applies with language packs. If we have PCs that are pointing to Windows Update for their servicing, when they get the new Windows 10 release from Windows Update, they'll notice that, hey, there's additional language packs on this machine. I need to download those and reinstall them as part of the process. That same thing doesn't work with WSUS or Config Manager. So in those cases, you need to build the set of language packs that you want to be reinstalled as part of that upgrade. You can put them in a folder and then pass that folder along to setup, and it will automatically take care of injecting them as part of the upgrade. That's using either command line switches again, or just like we were talking about before, setup config.ini can do that to just pre-stage that content on the machine. The other challenge that we have with upgrades is that the language that you use to do the upgrade with, let's say you've got Windows 10, 1607, Enterprise, EN-US Media. You can only use that EN-US Media to upgrade machines that are currently running with the system UI language of EN-US. Any other language, any other locale won't match, and as a result, the upgrade will fail. If you have all of your machines running the exact same system UI language, no big deal. You just make sure you start with the right media that matches the system UI language of all your PCs. If you're a multinational company that happens to have multiple different system UI languages, maybe because you have multiple different images that are used to deploy in different countries, then you're going to need different media to upgrade with each one of those. Now, we have seen customers that have worked around that by changing the system UI language, but that process is a little messy because first you need to make sure that the language pack is present. Like let's say you wanted to switch all your machines to ENAU. You could do that. You need to make sure the English language pack is installed first. But in order to make that switch, you would need to reboot the PC into Windows PE, run a DISM command to change the system UI language, and then boot back into the full OS, because you can't actually change the system UI language while the OS is running. You can only do it while the OS is shut down. So it's doable, but it does take extra work. The alternative would be to identify all the different system UI languages in use for all your PCs, and then target the appropriate media to each group of PCs based on the system UI language for each group. That can be scripted. We've seen a few examples of customers that have done it that way, so it's certainly doable. It just requires a little bit of work to script that up to detect what languages are actually being used. Let's take a look at that on my PC here. So I have a PC here running Windows 10, 15, 11. It's in the stage where it can be upgraded to Windows 10, 1607. But I want to make sure that it gets the language packs put back. So I can create a setup config.ini file that gets put into a very long folder structure, users, default, app data, local, Microsoft Windows, WSUS, and that can contain one line for each command line switch that I want to add. So in this case, I could specify install langpacks equals, and then the path to a folder containing language packs. In that folder containing language packs, I have a subfolder for each language pack that I want to install. If we look inside of that folder, that is the Spanish language pack. All that's in there is the lp.cab file, which is all of the language resources needed for Spanish. So you can build out that with as many different language packs as you need to inject as part of the upgrade process, and it will make sure that it puts all those back. Same basic process for the encryption software that we talked about before, and for several other things that you can do, like drivers. When you upgrade from, say, Windows 10 15.11 to Windows 10 16.07, all the drivers get reinstalled. It will start with a clean operating system image. It will install considering the inbox drivers that are included in the image that you're deploying, plus the drivers that are migrated from the old operating system version into the new one. So it will pick up all the drivers from Windows 10 15.11 and consider those as it's installing Windows 10 16.07. There are a few drivers that are left behind, like display drivers and Bluetooth drivers. The assumption is that the inbox drivers included in the install.wim are always going to be better than the old drivers that were running on the older version. So there could be instances where you want to override that and specify additional drivers to be considered, or maybe newer drivers than what are included in the install.wim that ships with the media. You can do that just by creating a folder on the PC containing the drivers that you want to use, and then pass those along to setup with the install drivers switch. Just like before, if you can get to the setup.exe command line, you just add /install drivers and the path. Otherwise, setup.config.ini, you can put an entry in there that says install drivers equals :/drivers, or wherever you happen to put those. Now, what we would really like to get to is something that doesn't work very well right now inside of enterprise networks, and that's a process called dynamic updates. Dynamic updates enables the upgrade process to reach out to the internet and do a few things, like grab the latest cumulative update and inject it into the install files as they're being deployed. Grab the latest drivers from Windows Update, download those and get them ready to be reinstalled on the PC. Download the latest compatibility information so we can make sure we know about the most recent changes to the list of incompatible software so we can stop the process if we find one of those on the machine. But today, while that works great for PCs that are pointed to Windows Update, it doesn't work so well for PCs that are managed behind WSUS or behind Config Manager because they don't have access to the internet to get those. You could fix that. You could temporarily point the PCs to Windows Update so that they pull those pieces from the internet. But there are downsides to that too, like the size of what each of those PCs is going to download. The cumulative update could be 1 gigabyte. The drivers could be 300, 400, 500 meg, depending on the types of drivers they are. The compatibility database, at least that one's fairly small. That one's under 100 megabytes. But grand total, you're talking about 1 to 2 gigabytes worth of stuff per PC that would need to be downloaded. So we're trying to work on a process of getting all that content into WSUS so that we can point all the PCs to a local cache for that stuff and pull it from there. So we still have some work to do to get all that to work. Language packs, optional features, all of those different things that setup might need to reinstall as part of the upgrade process, we want to get into WSUS so it doesn't need to download that stuff and you don't need to do any post-processing after the upgrade. So we're not quite there yet, but we are making progress. As Bill mentioned earlier, the Unified Update program that we're working on is designed to address those challenges. So as we move forward, we want to greatly simplify this. We also know that size overall is a big challenge. So we want to be able to reduce the impact of updates on your Windows 10 PCs. There are two pieces to that. One is with the monthly updates, which grow every month because they're fully cumulative. And then the feature updates that come out about twice per year are effectively full re-releases of Windows 10. So if you look at the media, that's 3.5 gig worth of payload that would be deployed out to each Windows 10 x64 PC to upgrade it to the latest feature update. So that can be pretty significant, could have a significant impact on your network as that large set of data is being deployed out to each PC. From the perspective of feature updates, At least that's not done very often. You're talking about deploying 3.5 gigabytes about every 6 months, where the deployment itself is spread out over that 6-month period as you're doing one group of PCs at a time. The monthly updates actually become a bigger problem because you're doing that every month as we release new Patch Tuesday updates, and you generally do it much faster. So if a update comes out on Patch Tuesday, generally you will start deploying it on Patch Tuesday, which probably is already Wednesday here, and then the days after that, you're doing large numbers of PCs each day so that you could be done with this whole deployment for a new security update within less than a week. So if you think about that, having 3.5 gig for a feature update spread out across 6 months for each PC, or having, say, a gigabyte monthly update where you're pushing it out to every PC within a period of several days, those monthly updates are a much bigger concern. Obviously, we need to come up with some solutions on reducing the impact of both of those, but we're focused more on the monthly impact right now as we can make longer term plans for the feature update issue. So let's dig in a little deeper on both of those. First, talking about feature updates. Now, I kind of stated very specifically that 3.5 gigabytes is the size of media. So if you wanted to take a PC from Windows 10 15.11 to Windows 10 16.07 using the media that you download from the Volume Licensing Service Center, if you look at the size of that media, the contents of the ISO, it's 3.5 gigabytes. Well, you really don't want to deploy from media if you can avoid it because it's 3.5 gigabytes. If you were to use the content that's on WSUS or what's being deployed by Config Manager's Windows 10 servicing, which comes from WSUS, or if you're pointing PCs directly to Windows Update or Windows Update for Business, all of those don't use media. They use ESD files, electronic software distribution files, which are compressed differently, and as a result are only about 2.5 gigabytes. So you can get a 1 gigabyte per PC savings just by deploying the updates differently. Don't deploy them using media, which generally means task sequences. Instead, use a servicing-based approach using WSUS, Windows Update for Business, or Config Manager's Windows 10 servicing feature. So we make progress. We can reduce it by 30% just by switching to ESD files. As we move forward, though, we want to make that process even better. Bill also mentioned that in the previous session that we're working on a differential upgrade capability. That differential upgrade capability starts from those ESD files. So we need to be using a servicing-based approach. But once we have that servicing-based approach in place, we can then be smarter about how much we download to each PC. Rather than downloading the entire install.wim, we can just download the files that have changed. So we can analyze what's currently on the PC compared to what's in the WIM file, the ESD file that we're using to do this deployment, and download just the byte ranges for the files that have changed. We believe that will reduce the size by about another 35%. So instead of having 2.5 gigabytes, we're now down to somewhere around 1.8 gigabytes. So we started at 3.5, we moved to 2.5 with ESD files, and down to about 1.8 using the differential upgrade capability. So it's about half the size of where we started from. Still big, so we would still recommend that you have a peer-to-peer distribution mechanism in place to reduce the impact on the network even more, but it's more manageable. It's not the full 3.5 gig that most people are afraid of. In the case of the differential upgrades, after we've downloaded everything that's changed, the upgrade process itself works exactly the same as it does today. So it's still going to take 30 to 60 minutes. It's still going to do the standard in-place upgrade that you've probably already seen. So no changes to the process other than a smarter download to get the process started. You will see in the creators update that in order to support this, The metadata on the files themselves will be a little bit different, because if we recompiled Windows builds every day and we changed the version number of the file every day, guess what? The file would be different every day. So we've had to make some tweaks to the way that we build Windows in order to support this, but it won't have any impact on anything beyond the servicing process. So we need to have two things in place for this to work. Well, more like three. First, we need to have a baseline build in place where we can start keeping track of what files have changed. That baseline build is the creator's update. We then need to deploy the next feature update, which would happen later in 2017, where we can start doing this differential upgrade. So you don't see the benefits of this one until later in 2017. We also need to get all of the deployment and patching tools updated so that they know how to do this. So we've got some work ahead of us to get WSUS and Config Manager and all the third-party patching and management tools all set up so that they know how to deploy ESD files and they know how to do this differential upgrade in conjunction with the way the setup process works. If you have a management or patching tool where the first thing it does is download everything locally and then initiates the process, that kind of defeats the purpose of doing a differential download. So you need to have some potential re-engineering of the existing deployment solutions done. So as a result, we're working with all of those vendors, we're getting them educated on what this process is going to look like so they can start making changes, getting those in place hopefully around the middle of the year so that you're then ready to deploy using this differential upgrade process later in 2017. So let's talk about quality updates then. These are the monthly patches that we release with security and non-security fixes for existing Windows 10 releases. These have, well, they're always fully cumulative. So every month, the size of the full package keeps getting bigger. If we look at Windows 10 15.11, it's the example here, it started off in the first month of only being about 100 megabytes, but then it grew between 100 and 150 meg every month to get to the point where after a year, it was roughly a gigabyte. If you're using Windows Update for Business, or WSUS, those are smart enough to just download the Express packages. Those Express packages are just the delta. Kind of like that differential upgrade that I talked about before. The Windows Update agent is smart enough to figure out which components have actually been updated and then only download the deltas that are necessary for those particular updates. So with Express updates implemented, the downloads are roughly about 100 megabytes per month. You never had to download those full packages. You just download the byte ranges containing the changes that you want. If you're using WSUS, WSUS fully supports Express updates, but you have to turn this feature on. It's a checkbox in the WSUS settings to enable that. Once it's enabled, then we can be smarter about what we download. The big challenge, though, has been Config Manager and third-party products. So we need to enable this for other third-party products by making similar types of engineering changes like I talked about before. They need to understand, don't download the whole package and then tell the Windows Update agent to download from this folder on the C drive. Instead, you have to have a mechanism of distributing the content, but then being able to point the Windows Update agent to that content for it to download just what it needs. So we've had to expose new APIs in Windows 10 to enable this. We released some updates in January with the first capabilities around that. We'll probably have another update in the next couple of months to fix some issues with that. But once that's enabled, now products like Config Manager and some of the other third-party products like from Symantec and Landesk and others, they would be able to do an Express update, download, and installation. So we get to the point then where we're only talking about 100 megabytes per month rather than a gigabyte per month. That can be a growing problem as these updates continue to grow each month. Now, the downside of Express updates is that in order to make these work, the update packages that we hold on the server actually contain the delta for every single version of the file that we've ever released. So if you were to look at something like the NTOS kernel file, maybe we've patched that one 10 times. So as a result, the package contains 10 different deltas for that file so that we can patch any known version of that file to the current state. That means that these Express update packages on the server are much bigger than the full update packages that are on the server. Plus, we still need to have those full packages just in case we run into a scenario where we look at the PC and see something that doesn't match what we have delta packages to patch. So imagine we look at the checksum of the NTOS kernel file and it doesn't match any of the deltas that we're looking for. We're just going to say, nope, we can't use Express packages. We need to download the full package and install that instead. So first, you need the very large Express update packages, which are about 5 times what the fulls are, and you still need the fulls. So the net impact on your WSUS servers to hold all of that is you need about 6 times the disk space of what you have today in order to support the clients only downloading 100 megabytes instead of downloading a gigabyte. So it's just kind of trying to focus on what's truly important. What's truly important is that each client PC downloads the minimum amount possible, but you do need to have that extra storage on the server to support that. So that will be coming. We'll have some more to talk about related to that in the next few weeks as we work out the final kinks in this process to make sure that Config Manager and Windows 10 and Server 2016, for that matter, would be able to do this Express update installation. I mentioned before that having a peer-to-peer deployment mechanism is a great help with this, because the problem that we run into today is that every PC has to go into the data center to a distribution point or a WSUS server and download that content. So if you have thousands of PCs all going to one server and trying to download all this stuff, makes that one server and all the switches that are in place to get to that pretty overloaded. So with peer-to-peer, we just shift that traffic to push it out to the edges of the network. Once one PC on each of those network edges has downloaded that content, it can then share that content with all the other PCs in that network segment so that none of the other PCs need to go back to that more scarce resource in the data center. We have a variety of technologies available to do this with. Branch cache has been built into the OS for quite a while. Works very well with WSUS and Config Manager so that PCs that have already downloaded chunks of that content can provide it to other PCs. We also introduced a new capability called delivery optimization built into the Windows Update Agent, but that uses a cloud service to keep track of all the PCs that have already obtained the content. So the way that one would work is even if you have your PCs pointing at WSUS, they would scan against WSUS, they would figure out what updates need to be installed, but before they would download them from the WSUS server, they would reach out to the delivery optimization service in the cloud and ask, is there any PC near me that already has this content? So the delivery optimization service would look through its records, find a list of PCs on your network that have already downloaded that content, and provide back a referral to a list of PCs for it to consider. So that way they don't have to go back to the WSUS server. If there are no PCs available, if the list, none of them are reachable for any reason, it's always going to fall back to getting the content from the WSUS server. So it can always have a way of getting the content, but you hope that it can find a peer to get it from rather than always having to go back to WSUS. So it's all about redistributing the traffic, pushing it out to the edges of the network, and trying to be as efficient as possible. In the case of Configuration Manager, if you're using that, they've also added a new peer-to-peer capability built into the product. So the Config Manager client downloads the content into the Config Manager client's cache. Once it's done that, any other Config Manager client can get the content from that other client's cache. So rather than having to go out to the distribution point and download it again, it just pulls it from the PC that's sitting 2 doors down. So that's a new capability built into the product that really achieves the same thing. We've also seen a lot of customers around the world that have looked at other add-ons for Config Manager, like Adaptiva, who I think is here this week, 1E, and plugins that work on top of Config Manager to provide more advanced peer-to-peer capabilities to do these fan-out distributions with a whole lot of additional knobs and controls to let you fully control what content comes from where. So if you get into some more niche scenarios or more complicated scenarios that you need to work with, using those sorts of third parties can help with this as well. So let's talk about some of the other challenges around upgrading. One of the things that customers have complained about is that we have some apps included in Windows 10 that they're not overly fond of, like, I don't know, the music app or the Xbox app or things like that. And as a result, they want to get rid of those. Great, no problem. You can get rid of them as part of your image, but as soon as you upgrade to the latest feature update, they all come back again. We're aware that that's a challenge. We've published a variety of workarounds to help with that, but we do need to still do some more engineering work to solve that problem completely so you don't have to worry about that as we move forward. There are 2 phases to this. The first one is in the Creators Update. So when you deploy the Creators Update, any app that the end user has uninstalled won't be put back automatically. That's the first good step. The second step, though, is not going to come until later in 2017 with the next feature update after the Creators Update, because we need to keep track of what apps the IT administrator has deprovisioned from the OS, using PowerShell, using DISM to deprovision the apps from the OS. Today, we don't have any way of keeping track of those, so as a result, when you install a new feature update, they all come back again. Then the user signs in. When the user signs in, all the provisioned apps get installed for each user. So we will be adding logic in the Creators Update to keep track of what's been deprovisioned so that the next update that comes out will be able to avoid putting those apps back. So 2 phases, but we'll get there. So that means we still need to go through the workarounds like we've documented. And for those of you who haven't done that, it's not too bad, and in some cases the scripts that we publish to do this make it look a little bit worse than it probably really is. So let's take a look at removing the inbox apps. So in this case, let's assume that you've deployed Windows 10 15.11, and now you want to upgrade to Windows 10 16.07. You can work around the problem with the apps coming back by upgrading using media that doesn't contain the apps. So we will support that. It's one of the workarounds that's been documented. So I can take the install.wim and mount it and remove the apps from it, and then use that modified install.wim to actually do the upgrade to Windows 10 16.07. So in this case, I've already mounted that image just to save a little time. And then I can run get appx provision package path edemo mount to see what provisioned packages are present. And that'll take a few seconds. Coming back with the list. So maybe we don't want the Zune Music app included in the OS. Let me copy and paste there. Let's do get AppX provision package where $_ display name equals Zune Music. Let's see if we can select just that one app. Okay, that looks good. So then let's go ahead and remove AppX provisioned package. Oops. Using the same path that we had specified before, the mount path. So that's all it really takes to get rid of them. We just figure out which ones we want to remove and deprovision them from the install.wim. And then we can do setup.exe/auto upgrade using that modified install.wim. And in that case, it won't have the app present, so it can't possibly put it back into the new operating system. So that's a decent workaround. The downside of that workaround is back to what we had talked about before. This requires using media. And remember, the media is 3.5 gig rather than the ESD files, which are only 2.5 gig. There's no way to do this using ESD files because you can't mount them and make modifications to them. They're encrypted and checksummed, and they can't be modified. So in the case of ESD files, you would have to do this differently. The easiest way is some sort of post-processing that you run after the upgrade that then removes the provisioned apps before any user signs onto the machine. So as long as you get rid of those apps before a user signs in, they won't be there as provisioned apps, and therefore they won't reinstall for the user when they log in. But the blog that I posted back in, whenever that was, November, goes through all of those scenarios and talks about some of the other options. So you could do that via setup complete file, you could do that via scheduled task. If you're using task sequences to do this, you could use this, you could put a step into the task sequence after the upgrade completes. So it's a bunch of options on how to do that as part of the feature update deployment. It feels like we're constantly battling little annoying issues too. I mean, we're trying to make this as seamless of a process as possible, but there have been instances where we haven't always succeeded at that. We've seen issues where some settings don't get migrated. The funniest one was the numlock key. The state of the numlock key didn't get migrated as part of a feature update installation. Hey, we fixed that one, so that one's now resolved. But we've seen a few scenarios where the default apps would change as part of the installation of a new feature update. So if you had Windows 10 with your default browser set to Chrome, afterwards your default browser would now be Edge. Or maybe you had your PDF viewer as Adobe Reader, and afterwards it became Edge. We are aware of a few cases where we had bugs like that. Those should be fixed in the most recent cumulative updates, which goes back to the conversation around dynamic update and why that would be good to be able to get the latest updates injected into the process as part of the upgrade, so you get all those fixes. But even if you're not using the dynamic update process because you can't, because you're using WSUS or Config Manager, the alternative would be to just make sure that you inject the latest cumulative update into the media as you're deploying using that so that you get those fixes. With Windows 10 16.07, a lot of the issues that we fixed were actually resolved during the CBE period, the first 4 months after its release. So grabbing the latest media from the Volume License Servicing Center includes those fixes already. Using the refreshed content that we pushed out to WSUS in January also includes those fixes as well. But certainly any other issues that you find during the feature update deployment process where you see something that doesn't migrate successfully, let us know. You can certainly submit it through the feedback tool included in Windows. The challenge with that is we're still working on the Windows Insider Program for Business so that that doesn't get lost in the noise of the consumer feedback. So if you do have a support agreement in place with us, talk to your TAM, have them submit a bug directly to report any sorts of things that weren't migrated successfully. Because we want this to be as seamless of a process as possible, we will take all of those migration issues seriously and try to resolve those as we can with each of the releases that we come out with. We do have the ability to do a pre-flight check as well. So if you're going to do an upgrade, you can first run kind of the first half of the process. So we can go through the motions of doing an upgrade but not actually do the upgrade. So you can specify a compat scan only switch and run a simulation effectively where it will report back different return codes indicating what it found. It'll return back one return code that says I found no issues. It'll return back one saying there's not enough disk space. There's one for I found an app compat issue. There's one for I found a hardware compatibility issue. So you can then look at the resulting return codes and be able to see how big of a problem do I have in front of me. So that's doable. That's what I would consider the low-tech approach. The high-tech approach is let's just use Windows Upgrade Analytics, now called Windows Analytics Upgrade Readiness, to be able to gather all that up for you, because the upgrade readiness process is using the same compatibility checks in order to show you all of that information in the OMS portal. We'll talk a little bit more about that as we get into it. But if you wanted to do something quick and dirty, this works out pretty well. The one frustrating part about this is the design of this requires that the full media is available, including the install.wim. So if you're using Config Manager, don't try to do this with a package configured for download and execute, because it will download that 3.5 gigabyte WIM and then throw it away when it's done, because it won't actually do the upgrade. If you run it from the network, then it's just going to run the setup binaries from the network, which will check to see if the install.wim's there, but it won't actually use the install.wim. So you'll save a whole lot of network traffic. I mentioned before BIOS to UEFI conversion, the tool that we're working on, MBR to GPT. You can try that out with the current Insider Preview builds. I don't happen to have a machine with me where I can run through that whole process, but we can take a look at the tool real quick. Helps to be elevated. So if I run MBR to GPT, we can see that there's not a whole lot to this tool. The tool basically allows you to specify whether you just want to run through a validation to see if it's possible or actually do the conversion. So typically you would just run MBR to GPT/convert. All the other parameters are optional. You could specify if you had multiple disks, which specific disk do you want. You can control where the logs go. In some cases, you might need to map partitions. If you've got an odd configuration where there's multiple recovery partitions, you could have to tell it which recovery partition goes where. And then there's also an allow full OS switch, because we encourage you to do this in Windows PE, because that gets all the antivirus software out of the way and make sure there's no in-use files. And there's just a bunch of things that are just cleaner to do in Windows PE. But if you want to, you could specify /allow full OS, and it will do the disk conversion while the operating system is running. So you would run that command, you'd run the BIOS configuration utility provided by the OEM, and then hopefully as soon as possible reboot that PC so it comes back up in full UEFI mode. So try that out. If you search the internet for MBR to GPT, you'll find the MVP postings that show some task sequence samples on how to do that. We'll have more published in the coming weeks on more details around that as well. A few other things that have changed in Windows 10 16.07. We added a new active hours policy, which works well with Windows Update and Windows Update for Business, to control when the PC should be restarted. So you could specify this PC is typically used during these hours. Don't reboot during those hours. As soon as those hours end, then the PC reboots. That works pretty well. We've changed the Windows Update for Business policies. In Windows 10 15.11, you could specify whether to defer upgrades or not, and then you could specify the number of months that you wanted to defer between 1 and 8, and for the monthly updates, you could defer those between 1 and 4 weeks. With Windows 10 16.07, we made those more flexible. Now you can specify that you want to be a CB or a CBB machine, so just a little bit more obvious on the policies. But then you can specify for either one of those, how many days do you want to defer a feature update, or how many days do you want to defer a quality update? In the case of feature updates, you can defer them between 1 and 180 days. In the case of quality updates, I believe it's between 1 and 35 days or something like that. So a little bit more flexible than what we've had before. We've documented some more things around delivery optimization, including making it clear that delivery optimization is used with WSUS. So if you have Windows 10 15.11 or 16.07 in place and you start to notice this internet traffic being generated every time the Windows Update agent goes to install something, that's why. It's checking with the delivery optimization service. There are policies that you can use to turn that off if you don't want that to happen. The best reason to turn that off would be if you're using branch cache, because you don't really need two peer-to-peer mechanisms fighting over which one should cache the content. So you could turn off delivery optimization and cause it to use bits to do the download, and therefore then branch cache would take over and be able to give content from other peers that are around. But you can see the blog that I posted back in August around that has a lot of detail for that, and we published new content actually based on the blog to TechNet as well to explain that more deeply. I need to update my slide now because it's no longer Windows Upgrade Analytics, it's Windows Analytics, Windows Analytics Upgrade Readiness. If you haven't tried this out, we'd encourage you to try it because it's free and it's really simple to set up. In order to set this up, you sign up for a free OMS subscription that gives you the necessary pieces that you can use to visualize the data and to drill through it. You get a commercial ID, which is nothing more than a GUID that you can tag all your PCs with to indicate all these PCs belong to your organization, because otherwise, telemetry that gets reported back to us is anonymous, and because it's anonymous, we couldn't possibly group it together and show you here are all your PCs. So that's what the commercial ID is for. It groups all your PCs together and shows them through the Upgrade Readiness console. So you can sign up for that, try it out. The new one that was announced to go along with this is the Windows Analytics Update Compliance Solution. The Update Compliance Solution is designed for another challenge. Like let's say today you're using WSUS for your patching. WSUS includes some reporting capabilities, so you can actually see which PCs have been updated, which PCs aren't. Okay, let's say you switch over to using Windows Update for Business, where you point all of your PCs directly to Woo in the cloud. You use that with delivery optimization for peer-to-peer transmission of the content, but you had no way to measure compliance, to be able to see which of my PCs have been patched, which ones haven't. So the Update Compliance solution is to show you that information, to be able to show you that all of my PCs are being updated, or if they're not, which ones haven't, and hopefully, why haven't they? Maybe they're having some issues. Maybe they don't have enough disk space. Maybe the Windows Update agent isn't running. Who knows what the issue is, but we should be able to drill into that list of unpatched PCs and figure out what's going wrong with them so that we can take some corrective action to get them fully patched again. In some cases, it might just be that, hey, they haven't checked for updates recently. They haven't been on the internet. Maybe the person's on vacation and the PC's turned off. So there are valid reasons that that can happen, but if that continues on for months, then there's more investigation that's needed. So the two pieces that we had talked about, if I push the right button. One of them is the Upgrade Analytics, now becoming upgrade readiness. We can drill into the data that's been collected for that and use that to kind of walk us through the process of how do we get ready to deploy a Windows 10 release to all the machines in our environment. So the big focus is going to be on applications. We want to know what apps we have and what issues may occur on those applications. Then we can work through the process of remediating those issues, drilling into the specifics in some cases, like maybe a fix is available for an app and we need to deploy that fix. Then we can begin deployment, so enable us to focus on the PCs that are best candidates for early deployment so that we can get feedback from those PCs to confirm that we're ready to expand to larger pilot groups. That's really the goal. We don't want to do as much upfront testing of applications. Instead, we want to deploy to a pilot group, see if we get any negative feedback. If there is, resolve that feedback. If not, make a bigger group and just keep expanding out to larger and larger groups, getting ready for the CBB declaration where we now say it's ready for broad deployment, so that once that point occurs, we're now ready to go full speed ahead. Where at that point we shift focus to instead say, now it's just about risk reduction. We think all of our apps are in great shape because we've gotten really good feedback from our pilot participants, which represent 10 to 20% of the PCs in the organization, but use 90% of the apps that exist in the organization. That's kind of the goal. Can we identify that 10 to 20% of PCs that use 90% of the apps? Generally, that's not too hard to do. But once you've gotten good feedback from that group, now you're ready to deploy broadly. It's just about making sure you don't cripple the business. Like, let's say you decide you're going to deploy to the entire accounting organization at once. That's not what I would consider a good career move. So instead, let's deploy to 1/3 of the accounting group, and then another third of the accounting group, and finally the rest of the accounting group. That's the type of deployment rings that we want to do. Initially for piloting, it's to continue to expand to the point where we've covered the biggest population of apps. But once we get to the broad deployment phase, it's all about risk reduction to make sure that we continue to have jobs. We also have new capabilities around Office, because we hope that you'll consider deploying Office 365 Pro Plus, Click to Run, at the same time you deploy Windows 10. And the biggest challenge usually with Office is add-ins. So we've started to collect an inventory of Office add-ins so that you can see what add-ins are in use inside of your organization and use that to focus your testing and validation efforts to make sure that all of these add-ins work as expected with the Office 365 Click to Run. We also have some site discovery capabilities to inventory the websites that are being visited by a group of users inside your organization. Now, this is an opt-in thing. It's not on by default because there's probably something you don't want to know about your users, so turning this on and having every single website they visit collected, not recommended, but this can be configured to say, only grab internal websites, only grab sites visited from this list of domains. So you can filter this down to a smaller list of sites, but we'll inventory not only the site that's been visited, but the document mode of the page that they retrieved, and just more information about the websites that help you with the configuration of enterprise mode with IE11 to support these legacy websites that might be in use inside your organization. So definitely try that out and use these tools to walk you through the process. They're as cheap as they can possibly get because they're free. Ready for Windows is one of the sources of information that actually gets fed into the upgrade readiness as well, because you want to know as much as you can, really. You want to know about the apps that are in your environment, whether those apps have any known issues, but also it's nice to know what apps are actually being used by lots of other people. So we could search for a particular app. Maybe if I search for Citrix, I can see Citrix Receiver shows up at the top of the list. I get a simple support statement here. It says that it's supported on Windows 10. If we click the Learn More link, it takes us to Citrix's website where they document what's going on there. But then we can scroll through all the different versions of Citrix Receiver that we can see on the hundreds of millions of PCs that exist out there running Windows 10 and sending us telemetry. And for each one of those versions, we can see usage information. So we can see right now that, yeah, Citrix must be churning out lots of new versions because they're not very heavily used. We see insufficient data. But if we go back to 14.6, we can see that that version is highly adopted. In our terms, highly adopted is something like hundreds of thousands of PCs. So if there are hundreds of thousands of PCs running this particular version of Citrix, that's a pretty good sign that this version of Citrix must work reasonably well on the Windows 10 release. So you can use this sort of data to prioritize your testing and focus in on the apps that are more specific to you, the ones that are going to be more lightly used by the rest of the world at large, and really just try to minimize the amount of testing that you use going into this. So that one's free. You can certainly try that out. It works pretty well to search through the apps that are available out there and see the data that we have on each one of those. We have lots of tools that we've talked about as we're going through this. We hope that a lot of people will consider Windows Update for Business as kind of a longer-term direction on keeping your Windows PCs up to date. For most PCs today, they're probably using either WSUS, System Center Configuration Manager, or a third-party equivalent. Those work fine. There are some specific requirements for those, and they will need to make some engineering changes for the differential upgrade and express update things that we had talked about before. So then let's talk a little bit more about modern deployment. For modern deployment, the idea is different. We want to be able to take a new device off the shelf, plug it in, turn it on, and transform it into something that can immediately be used. In order to do that, we have a few different solutions, a few different mechanisms. The one that's most interesting is the cloud-driven one, because that doesn't require IT to touch the device. We want to be able to send this device directly to the user, assuming they can figure out how to open the box, plug it in, turn it on, and have the rest of it just be set up for them. Rather than having to send them a 36-page document that says walk through all of these steps, we want them to just turn it on, put in their email address, put in their password, connect it to whatever Wi-Fi network is nearby, and the rest gets pushed down to the device. That's what we want to get to with a cloud-driven scenario. We have some scenarios related to that implemented in Windows 10 already, to be able to use Azure Active Directory with automatic MDM enrollment to tie this machine into Intune or other third-party MDM services. We want to extend that with the Creators Update to also be able to automate more of the UBI process so that you don't have to click through as many screens to simplify the experience for the end user. And then as we move forward farther down the line, we want to make that even easier to the point where they may not even have to type in their email address. We would know that this device belongs to the organization, and when it's turned on for the first time, should provision itself. That's what we want to get to using a service in the cloud where you've registered these devices at the point of purchase so that we can configure them automatically. We do have some manual capabilities if you want more of an IT-driven process, but we want to get to the point where that's really for smaller organizations that may not have the sophistication of using that cloud-based approach. Using the Windows Configuration Designer, which used to be called the Windows Imaging and Configuration Designer. We're dropping the imaging piece, so Configuration Designer is all that's left. But using that, we can create a provisioning package, which is kind of a self-contained package of settings that needs to be applied to the machine. We just don't provide a way of getting that to the machine. So as a result, you have to figure out some way of getting that. So that's where the IT part of this comes in. You create the provisioning package, put it on a USB key, but then you can take it to each new machine that you're setting up, hit the Windows key 5 times, browse to the USB key, select the provisioning package, and apply it to the machine. Great for the less sophisticated organization, okay for small, medium-sized businesses, but not something you want to do at a large scale. If we go to the other end of the spectrum with teachers and people who are doing this in small schools where they're not really even IT people, they're just people who've been told they're IT people, they want something even simpler. So we've created a Set Up Your School PC app where it walks you through a simple wizard, asks you to insert the USB key, puts all the files onto the USB key for you, and then you can just take that from PC to PC and set up a classroom full of machines. So we want to be able to cover that entire spectrum from the non-IT person that has to figure out how to act like an IT person, all the way up through the sophisticated organizations who want full automation around this. So we've been working on additional capabilities. In Windows 10, 15, 11, we added to Windows ICD the ability to run scripts and executables. In 1607, we're going to add some new things like some new wizards. We'll add the ability to do AAD bulk enrollment, so you can actually use a provisioning package to join the device into Azure Active Directory. Really, it's all about trying to do just enough configuration on the device to get it to the point where it's managed, and then have the management tool, whether that's Intune or some other MDM service, take over from that point. Pre-installed software certainly gets in the way of this, and we're well aware of that. We've been having conversations with OEMs for a while trying to get rid of that stuff, but if you buy Surface devices, we don't preload anything other than a clean Windows image. We've heard from Lenovo and Dell and HP and others that they'll offer that as a service for their enterprise PCs. You have to ask, and in some cases pay a little bit extra to get that stuff removed from the PC, but it's a lot easier to start from a clean PC and then build up from there. But we will have some capabilities in Windows 10, 1607 where we can clean that stuff off for you. It's just a little time consuming. We can do basically a PC reset and drop the OS back to a base configuration, keeping the drivers and a few other critical things as part of that you can then build on top of. But it does take probably another extra 30 minutes to go through that reset process to get rid of the extra stuff. We do have the ability to change the SKU, and this enables us to do some new things. So we announced back in the middle of last year the ability to have Windows 10 subscriptions via the cloud service provider programs. So if you're really a small or mid-sized business, you would be working with a cloud service provider, a CSP, that provides you with licenses for Office 365 and EMS and now Windows as well. So you could get a monthly subscription license to Windows 10 Enterprise. And while that's great, if we didn't have a great way of enabling Windows 10 Enterprise on their existing Windows 10 PCs, then they would never get any value out of it. So what we created was this ability to automatically step up from Pro to Enterprise for any PC where a user signs in that has one of those licenses assigned to them. So it works just like O365. You assign a license to the user. The next time they log into Windows 10 Pro, it becomes Windows 10 Enterprise and turns on all the enterprise features. That's great for CSP. What we're doing for the Creators Update is extending that to enterprises as well. The process that you would need to go through is acquire basically an unlimited license that you could put into your AAD tenant, and then assign those licenses to all the users that you want to enable that for, and then any AAD joined PC joined into the cloud could automatically go from Pro to Enterprise just by the user signing in. If you take the license away from them, it automatically steps back down to Pro. So very nice capability for AAD joined devices. And it also solves the activation challenge, because if you've got an AAD joined PC, it's not going to have access to a KMS server. So instead, we can leverage this cloud service provided as part of AAD to license and activate the machines. We will be doing AAD bulk provisioning. We're working on that. It's close to working in the current builds, just not quite there yet, but we'll get there shortly. On the traditional deployment side, each Windows 10 release, we come out with a new ADK. That's our full collection of deployment-related tools. We released one with Windows 10 16.07. It fixed all the known issues that we had at that point in time, but it did introduce one new one. If you're using 8021X, the version of Windows PE in the new ADK breaks 8021X. We'll fix that in the next release when it comes out. We did add support in USMT for Office 2016, so it can migrate Office settings. We added in some new components that used to be part of MDOP, since now AppV and UEV are built into Windows 10 Enterprise. It didn't make sense for us to say, go download MDOP, so now we've just put those tools into the ADK. We did remove the AppCompat toolkit pieces that really were kind of obsolete as soon as we had the Windows Analytics upgrade readiness piece, so those aren't in the kit anymore. We did update the Microsoft Deployment Toolkit. There was a new release that came out in November, primarily bug fixes, although there was some new changes implemented to support Windows Server 2016 and the roles and features that are included in that. We will continue to update MDT as needed for Windows 10 releases and to fix any bugs that we run into. You probably won't see us adding a whole lot of functionality because we see the future as the modern deployment that we had talked about, not the imaging scenarios, but we'll continue to make sure that everything continues to work and functions fine. In the config manager case, the hope is that longer term we can take more of the ZTI and UDI pieces out of MDT and merge those into config manager, so you don't always have to install MDT on top of config manager. We changed the naming too because it didn't make sense to do MDT 2013 update 3, update 4, update 5, etc. So now it's just MDT. So we've dropped the year and update number. So now to tell the difference, you need to look at the build number. So it's MDT 8443 is the current build that we have released. The next one when we come out with it will likely be MDT 9000 and something. So we'll just keep revving the build number to indicate that this is a newer version. Config Manager has implemented their current branch model. It's important to keep in mind that they support N-1 releases for Windows 10 releases. So when the Creators Update comes out, let's say that comes out in spring, we're in seasons flip, so fall, when the Creators Update comes out, the current version of Config Manager at that point in time is likely going to be 1702. So that new Creators Update will be supported by Config Manager 1702 and 1610. If you're still running 1606, the one that came out before that, then you'll have to upgrade that to at least 1610 to support Windows 10 Creators Update. They do have an insider preview, a technical preview branch that you can install in your lab so that you can see new features that are coming along, so try that out. They do have two mechanisms that we've talked about already for deploying feature updates. One is task sequences, which are okay because they let you do pre and post processing, but they require that you use media, which is going to be 3.5 gig. We really want you to use the servicing approach, which is only 2.5 gig. We already talked about sysprep. You can now do it. Don't do it. We've added the ability to configure the taskbar. So with previous Windows 10 releases, you could configure the Start menu, but you couldn't configure the taskbar. Now we've added support for doing that. Let me see if I can wake up my machine here. Let's look at the taskbar real quick. If I can remember which machine it was. Taskbar. Bar 001. So the way that you configure the taskbar is that you create a XML file that contains the layout that you want. So in this case, I can look at layout modification.xml. This one says that I want to configure the taskbar and I want to add an icon for Paint and for the command prompt. So if we look at the layout right now, the command prompt's only there because I've got it open, but there's no Paint icon here. I placed that file in User's Default App Data Local Microsoft Windows Shell, and now if I log out and log back in again, hopefully we will see 2 new icons pop up. So it's fairly flexible. It lets you specify that you want to append new icons to what's already there. You could say to replace the complete layout with a new layout that I've specified. If for some reason you want a different default browser, you can get rid of Edge and put in whatever other icon you want. So fairly flexible on the layout there. I would just point out that follow the TechNet documentation for that very closely, because the XML layout format is very specific when it comes to XML namespaces. So copy and paste from the samples on TechNet and then modify just the icons that you want to change. So that way you'll make sure that you get the rest of the namespaces right. And that's it, which is good because I'm a few minutes over. If there are any other questions, you can certainly find me around at the gathering this evening and around the rest of the week. If you have any other questions, you can probably figure out my email address too, mniehaus@microsoft.com. Hopefully I'll see some of you tomorrow in an imaging session where we'll talk more about building Windows 10 images. And then at the end of the session, I'll probably tell you don't do this because, hey, we want to do modern deployment, but we're not there yet. So thanks a lot.